Welcome to our Research Methodology series. Today, we are diving into a fascinating and crucial topic, royalty and commercialization. Have you ever wondered how a brilliant discovery in a university laboratory actually makes its way into the hands of the public? Or how researchers and universities fund their next big breakthroughs? It is not just about publishing papers. It is about bringing ideas to life in the real world. In this session, we will uncover the business side of science, exploring how inventions are marketed and how creators are fairly compensated for their hard work. Let us get started. To begin our journey, let us understand what commercialization actually means. Imagine you have spent 5 years in a university laboratory and finally invented a revolutionary new water filter that removes all known toxins. It is a brilliant scientific discovery, but if it just sits on your laboratory shelf, it doesn't actually help anyone in the real world. To make a difference, you need a company to manufacture it, package it, and sell it globally. This entire journey of taking an idea from a research lab and turning it into a product that people can buy is called commercialization. It is the vital bridge that connects brilliant academic ideas to everyday consumers who desperately need them. Now that we understand what commercialization is, let us look at how it works and why it is so important. The process involves multiple complex steps, including protecting the intellectual property through patents, finding investors, scaling up manufacturing, and marketing the final product. For researchers, this means transitioning from purely academic goals, like publishing papers, to business-oriented goals. Why does this matter so much in modern research? Without it, many life-saving drugs, advanced software programs, and green energy solutions would never leave the pages of academic journals. Commercialization ensures that society actually benefits from the billions of dollars invested in scientific research every year. Furthermore, the profits generated are often funneled back into universities, providing crucial funding for future discoveries. This brings us to the financial motivation behind commercialization. To understand if a product is financially viable, we look at a simple economic model of profit. The formula is P equals V times the quantity P minus C minus F. Let us break down where this comes from. Your total profit, P, depends on how many items you sell, which is the volume V. For each item, you make money based on its selling price, P, but you have to subtract the cost to make that single unit, C. Multiplying volume by this per unit profit gives your gross earnings. Finally, you must subtract your fixed costs, F, which include the initial research, development, and patent filing fees. If you increase the selling price or decrease the manufacturing cost, your total profit will increase, making the effort highly successful. Before we move on, let us see this formula in action with a concrete example. Suppose a university research team develops a new educational software. They spend $50,000 on research and patenting, which is our fixed cost, F. They sell licenses for $100 per student, so price P is $100. The server maintenance cost per student is $20, so variable cost C is $20. They sell to 2,000 students, making volume V 2,000. We want to find the total profit. First, we calculate the profit made on each individual unit by subtracting the variable cost from the price, giving us 80. Next, we multiply this per unit profit by the 2,000 units sold, yielding 160,000. Finally, we subtract the initial fixed costs of 50,000. The final answer is a profit of 110,000. This substantial financial return can now fund new research projects. Now that we have seen how products are commercialized, we must ask, how are the original inventors compensated over time? This introduces the concept of royalties. Think about a famous author who writes a best-selling novel. They do not just get paid once when they finish writing the book. Instead, they receive a small percentage of the money every single time a copy is sold. This concept applies exactly the same way to scientific research. When a researcher invents something and allows a big company to manufacture and sell it, the researcher gets a cut of the sales. A royalty is a legally binding payment made by the licensee, the company, to the licensor, the creator, for the ongoing right to use their intellectual property. It is a fantastic way for inventors to earn passive income. Understanding what royalties are leads us to why they are absolutely crucial in the world of research. Royalties provide a strong financial incentive for researchers to innovate and share their findings with the world. Without the promise of royalties, researchers might keep their discoveries secret, or they might simply lack the motivation to go through the grueling, time-consuming process of patenting and commercializing their work. Furthermore, royalties serve as a vital protective measure. They protect the original creators from exploitation, ensuring that massive corporations cannot simply steal an academic's life work and make millions of dollars without fairly compensating the person who actually invented it. It ensures a fair balance between the business world and the academic world. So, how exactly do we calculate these payments? The calculation of a standard royalty payment is straightforward and relies on a simple percentage-based mathematical formula. The formula is R equals R times S. Conceptually, this just means taking a slice of the total sales pie. The symbol R represents the total royalty payment that the researcher or institution will receive. The symbol R represents the royalty rate, which is usually a percentage agreed upon in the licensing contract, expressed here as a decimal. For example, a 5% rate becomes 0.05. Finally, the symbol S represents the total sales revenue generated by the product over a specific period. If the product becomes wildly popular and the sales revenue S increases, the total royalty payment R will increase proportionally, directly rewarding the researcher. Let us apply this formula to a practical scenario. Imagine a biomedical researcher who invents a new type of surgical scalpel. The university patents it and licenses it to a medical supply company. The agreement states they will receive a royalty rate of 6% on all gross sales. In the first year, the company sells $500,000 worth of these scalpels. We need to find the total royalty payment. First, we must convert the royalty rate from a percentage into a decimal so we can do the math. A rate of 6% becomes 0.06. The total sales revenue, S, is given as $500,000. We multiply these two values together, 0.06 times 500,000. The final answer is 30,000. The company must write a check for $30,000 to the university, rewarding their innovative contribution. The basic formula we just used is great, but real-world agreements can be more dynamic. This brings us to tiered royalty structures. In the real world, licensing agreements often use a tiered structure to encourage companies to sell more products. Instead of a single flat rate, the agreement applies different royalty rates to different sales thresholds, or chunks. For example, a lower rate might apply to the first million in sales, and a higher rate kicks in for any sales above that amount. This tiered system is highly beneficial because it heavily rewards the researcher when their invention achieves massive commercial success. It shows just how flexible and lucrative intellectual property agreements can be when a research product truly disrupts the market. Let us see exactly how a tiered structure is calculated. Suppose a researcher licenses a new battery technology. The agreement pays a 5% royalty on the first 1 million in sales and an 8% royalty on any sales above that. The company sells 2,500,000 worth of batteries. What is the total payment? First, we break the sales into tiers. Tier 1 is exactly 1 million, multiplied by the lower rate of 0.05, giving 50,000. Next, we find the remaining sales for Tier 2 by subtracting 1 million from the total, leaving 1,500,000. We multiply this by the higher rate of 0.08, giving 120,000. Finally, we add the royalties from both tiers together. The final answer is 170,000, proving how lucrative successful commercialization can be.
Having calculated these financial returns, let us visualize the entire ecosystem. Here we see the flowchart of research commercialization. On the far left, the journey begins with academic research and invention. Once a discovery is made, we move to the second box, patent and intellectual property protection. With the idea secured, it flows into the third box, commercialization, where the technology is licensed to industry partners. This leads to the final box on the right, product sales in the market. But the process does not end there. Notice the dashed arrow looping all the way back from product sales to academic research. This represents the royalty payments. It beautifully illustrates how the money generated in the market flows back to fund future research, creating a continuous, self-sustaining loop.
We have covered a lot of ground today, so let us summarize the key takeaways. Commercialization and royalties represent the vital business side of scientific research. Remember that commercialization is the physical process of turning a laboratory invention into a marketable product that people can actually use. On the other hand, royalties are the financial mechanism that ensures creators are fairly paid for their intellectual property. Together, they create a powerful, sustainable cycle of innovation. By bringing products to the market, society benefits immensely from new technologies and life-saving drugs. Simultaneously, through royalties, researchers receive the funding and motivation needed to return to the lab and make their next great discovery. You now understand the complete journey from lab to market.